Hello, so in this video we're going to look at the A-Level Further Pure 2 exam paper from June 2019 by Edexcel. Quite a challenging paper, lots of mixed topics across the whole Further Pure course. A lot of this would be similar to a lot of degree level stuff. So if you manage to give the paper a go and manage to complete it in time, then a massive well done to you. If not, don't worry, see how much you can get done. Sort of a general tip I'd give for this exam is just to take your time a little bit, mainly because even though it is very time pressured, it's getting that accuracy with some of it is quite important. But also budgeting your time. You'll find that some questions in this exam are very long-winded and can take a while to do. Some of the other questions you can get done very quickly. So I would definitely recommend when you do an exam like this, just first couple of minutes, do just skim through and see how long it you think you to work out some of the questions. So let's have a look at this first one. So we've got a complex number. It's represented by a point in an Argand diagram, and we're given this equation for it. So the intersection of two circles, possibly, or stretched out one, and show that the locus has got this equation. So we want to show that these two things are equivalent. So this is the same as this. That's for part A. And for part B, we want to find the maximum value of the modulus of z. And just a quick note to remind you that is the distance from the origin of where z is on the object that we're going to get. So it looks like, look at this looks like the equation of a circle. So this will be the maximum distance from the circle to the origin. So let's get started. So in general, with complex numbers, it's so often easy to square these things, because if I've got z minus 3 squared, I know that that's a circle centered at the real number 3. So I can draw that, and similar with the other one. So it's better to square things first. So we're first going to look at z minus 3 squared. Now, hopefully you can transfer quite quickly, but z being x plus iy, I'm going to get x minus 3 squared plus y squared from this. And then from the other term, if I square it, I need to square the 4 as well. So I've got 16z plus 1 squared. So that's 16, I've got square brackets around that, x plus 1 squared plus y squared. And we're going to set these two things equal, so it's probably worth expanding the brackets that we've got. So using the binomial theorem to do it quickly, I've got x squared minus 6x plus 9 plus y squared. And well, for this one, let's take our time a little bit. So I've got 16, and then I do this with binomial, x squared plus 2x plus 1 plus 16y squared. So that's going to give me 16x squared plus 32x plus 16 plus the 16y squared. Okay, so let's try and set these things equal and see what we're going to get. So I've got x squared minus 6x plus 9 plus y squared, and that's going to be equal to the expression 16x squared plus 32x plus 16 plus 16y squared. Now let's rearrange everything to get 0, as we've got in this equation. So I'm going to make this side equal to 0, take away the x squared, that means we've got 15x squared. Rather than take away 6y, I'm going to take away 6x, I'm going to add 6x and get 38x. Rather than adding 9, take away 9 to get 7, and take away the y squared, I get 15y squared, and that's the same as the equation above. So we know that we've done that bit. It's a short question, so we can sort of have peace that we know we've done it correctly. We now need to find the maximum value of the modulus, which, as I said, was the distance from the origin. This here is looking to me very much like the equation of a circle itself. So let's try and complete the square and get it in our normal form for the equation of a circle. So I've got 15x squared. So let's factor out the 15. And I'm going to put it in square brackets. So I've got x squared plus 38 over 15 times x plus 7 plus 15y squared. Now let's click the square inside the square brackets. So I've got x plus, I need to half this number, so that's 19 out of 15. squared, take away 19 squared over 15 squared, plus 7 plus 15y squared. And this whole expression was equal to 0, so I need to stick with that because that's how we're going to get our equation. So we need to get our centre and our radius of the circle. Expanding out now, so 15 times that, and then times that term. So I'm going to have 15 times x plus 19 out of 15 squared, minus 19 squared out of 15 now, not 15 squared, plus 7 plus 15y squared. Now let's get our sort of number parts onto one side. So I've got x plus 19 out of 15 squared, still times by 15, plus the 15y squared, and that would equal 19 squared out of 15, take away 7, and then let's divide by 15 to get it actually into the equation of a circle. So I've got x plus 19 out of 15 squared plus y squared equal to 19 squared out of 15, back to the squared now, minus 7 out of 15. So let's put that bit in a calculator, I'm not going to waste time trying to do it in my head. So we've got 19 squared over 15 squared, subtract 7 out of 15. Okay, that gives us 256 over 225. Now if I square root that, that's going to give me 16 out of 15. So the answer to that is 16 out of 15 squared. So I know that's my radius. So in terms of a picture, what we're going to have, so 19 over 15 is bigger than 16 out of 15, so it's not going to touch the axis. We're going to have some sort of circle like that. Imagine that's a circle, not a great one. So we now need to think about, so this bit is the centre of the circle, so that's at minus 19 out of 15, and we know the radius is 16 out of 15. So we need to find the maximum value of the modulus of z, that's the maximum distance from the origin, which is going to be at this point here. It's not very well drawn on the diagram because it's not a great circle, but it's going to be there because that's when we get the furthest away. So let's we can work out the x value. So I know from here to here that is 19 out of 15 as a distance, and then the other part that we need, this bit here, is just the radius, which we've just said is 16 out of 15. So the maximum value of the modulus is just simply going to be 19 out of 15 plus 16 out of 15, which is 35 out of 15. Or dividing both by 5, that's 7 out of 3. So this question, compared to some of the other questions you'll see in the paper, was quite straightforward. I mean, it's question 1, so it's normally a good one to give a go. This one is probably one that's worth spending a bit of time on, making sure that you take each step slowly and accurately so that you're definitely securing those marks.